All right. Sorry, I'm trying out some new toys while we're doing this. I can never leave well enough alone. That ain't gonna work. My new toy doesn't even work. Whatever.
When will 102 show up in my Cisco Netacad thing?
After tonight, I gotta add you still. Well, you gotta add the course first. Did you?
I did that in Blackboard.
All right, so you're good. So I'll be good. All right, let's go ahead and get started. So this introduction is going to be a review of the topics in the first chapter of the Net 100 class. Now, just let me give you an idea here of a couple of things. First off, so in the Net 100, in the Cisco Networking Academy world, what we're going to be doing is drawing a giant frame around the world of networking to try to give you an idea of the world of networking, at least from the Cisco's perspective. But Cisco's perspective is a pretty important one because they're the leading manufacturer in networking, right? And when I say leading, dominant in networking, right? I mean, if you were to look at a pie chart of who owns the networking business, there's a little sliver that's everyone else, and then there's Cisco, right? So it just gives you, it's a pretty dominating picture. Although they're starting to shrink, right? You've got networking companies are eating market share. Cisco still owns a domination, yes.
Do they just do all the enterprise stuff?
Cisco is moved away from the low end, although they bought Linksys, but they're getting rid of it now. They have moved more into the enterprise space because that's where all the money's at.
Yeah, because like if you go in your store, you're not going to see a Cisco.
Well, you can buy a Cisco Linksys now, but Cisco's jettisoning the Linksys brand. So we'll see where that goes. But yeah, they're not really into the SOHO market, small office, home office market. What's that? Yeah, and that's why. You've got AT&T and companies like that are selling equipment, and they don't provide Cisco equipment. They provide the cheapest stuff they can. And
We got with our project, you just get this.
yeah, like Action Tech, right? Whatever the name might be.
Verizon's set up with a normal router, but they give you on the back a gigabit switch.
Yep. Yeah, networking, low-end networking has gotten so cheap that it's beyond commodity now, and so Cisco doesn't even want to deal with the market anymore. So they pushed into stuff, and now with all the virtual switching stuff going. Nowadays, when we talk about modern networking, we're no longer talking about actual physical devices. We're talking about virtualized networking, which is where the buzz is right now. So if you go to a networking conference, all they can talk about is virtualized networking, right? Soft switches.
At some point, all the computers in the world are just going to be one big computer.
Yeah, one big virtual sandbox, which is what Amazon would love, right? All right, so what we're going to talk about is just talk about basic networking topology. We'll talk about small and medium-sized networks, and I'll just cover the things that I want to focus on, and then we'll move on. All right. Okay. So, networks are following the similar cycle that processors have been following, right? There's this exponential growth issue going on, right? So, we've got, there's this idea that things have been moving, technology's been doubling every so often, but networks and the number of devices, number of IPs, the number of networking devices out there have been doubling every decade or so, and it's just getting crazy. So this is the way Cisco's kind of viewing the world. It used to be fixed computing. We have fixed devices with network wires running to them. We're now in the mobility or bring your own device world. BYOD has become the acronym that we talk about in modern business networks. The reason why we call it BYOD, because it used to be, and you would try to control the devices that your users would have. You have been issued a PC. You have been issued a laptop, right? But nowadays it's come to the point where so many have their own little devices that they like to use that we now are starting to build our networks more resilient so they can handle a bring your own device scenario. In fact, you're already starting to see it in colleges and universities. I pushed, even for this building, to no longer have computers on the desks, just to retrofit the rooms really nice for mobile computing, and then have funds available to buy people their own device or let them bring their own and get a credit. I failed, but that was a good try, right?
Maybe that's
So that would have been cool. But then you would have all the accessibility that you needed to get connected and all the software you required. And I'd rather have spent our funds on that than a bunch of devices. But we're a long way before people will swallow that idea. But now we're moving away to the Internet of Things, where devices become Internet accessible. And we're already kind of in that. Refrigerators and anything else you can think of, right? I mean, what has an IP nowadays? I mean, you can almost think about almost everything. Glasses now have an IP, right? You know, watches are getting IPs, and it's the personal area network type of thing. I mean, home automation is now the new buzz, right? And so home automation now has IPs on everything, thermostats, and who knows, right? So light bulbs now have addressable addresses on them, so you can know when they're dying, I guess, how much energy you've expended. But you know, that kind of thing. So yeah, have you seen them? You're looking confused. They actually have them. You can go buy them now. A light bulb with an IP address on it, and you can remote manage it from software. You can remote manage your light bulb. Yeah. Now how many network guys does it take to change a light bulb? So then we're getting to the Internet of Everything, which is what Cisco's calling this. I don't know how true that is, but we don't know where it's going to be in 2020. But we'll get to where everything will be Internetized, right? And so just imagine what that world will be like, right? And that'll be pretty interesting. So just imagine the networking person is going to have more and more requirements to understand this stuff, right? So you are the next army of people that will support this type of converged world, which is where we're heading, right? No doubt.
They showed a lot of this at Cisco had a big to-do at CES this year.
Yeah.
Went to CES
Yeah, great.
in Vegas, and they were demonstrating this whole thing. They were showing, you know, a mother pulling out her iPad. She can tell where her kid is in the entire neighborhood. If he's staying over at a friend's house, what video game he's playing, everything, right from her iPad.
Yep.
It's a little much, but they were demonstrating this Internet of Everything.
Yes.
You know, where he's at on the school bus route. Did he get dropped off at the right stop? Everything.
I think they call it the Mama Bear, Papa Bear.
Yeah.
Something like that, yeah.
Yeah, it's a pretty cool conference.
It's real.
There's Cisco has a giant networking academy conference every year. Students are welcome to go. If you're interested, I'll let you know about it. But they have, I think it's in San Francisco this year, and you can go up there and hang out and see a lot of this cool stuff. But like, for example, I have a contract with a company called Ingram Micro, and I do some work for them. And they have this set up down in there with their solution center. And basically, they can have these virtualized conferences to any one of their facilities throughout the United States. And so this is a very common way of meeting now. And this is just an idea. But the concept is we're starting to become a global connected community, or at least the people that have money are now a globally connected community. And that's a whole political discussion we'll have about later. But anyway, so networking is becoming everywhere. And of course, we have to deal with networks of all different sizes. Small offices like your house, a small office, a large network, and networks that span large distances. All the requirements may be different or slightly different depending on the needs. So we need to understand all these issues. Now, networks still work on this concept of client-server, and we'll talk more about this. This is kind of the older way of viewing networking, but it's still very common, and we need to understand it. Networks are based on this idea of a client-server. So it used to be we would have a server ran the show, and terminals would connect to the server. In a lot of ways, it's kind of become that way again in some aspects with cloud computing. But networks became very popular because it was very inexpensive to hook up a bunch of PCs and network them together and start sharing resources. So what kind of resources can we share? Printers, files, applications. And so a lot of applications are written around this client-server modality. And so you see, you got web servers, email servers, file servers, print servers. All of these connect together with some sort of networking devices. This particular one shows you a switch. In the internet world, we've moved to internet standards, where it's still based on client-server, but they're all using common protocols. Mail protocol like SMTP, web protocol, HTTP, file protocol, FTP, and other different protocols where we're using a standard block of protocols. This has made networks more heterogeneous. Apples have no problem talking to Windows machines nowadays. Back when I was a kid, Apple talking to Microsoft was like not going to ever happen. But now it happens all the time, right? Because we're on the internet. Okay? So there's different ways of looking at networking. And I'm not going to spend a lot of time on this. Your curriculum does, so I won't reiterate it. You can read it. But we started out with this kind of this peer-to-peer idea. When I was a kid, my first network was between two PCs over a coaxial network run. And I had this real intense pressure for those two machines to communicate because I wanted to play some game. I think it was like Duke Nukem or something. I don't know. It was some game. And I wanted to connect these games to talk to each other. So I had to run a coaxial cable from machine A to machine B. And I ran the coaxial cable down the hallway and hooked the two machines up. And after a weekend of agonizing work, got it to work. And I finally was able to play my first PC game across two machines. Boy, that was exciting. But that would be a peer-to-peer network. And so peer-to-peer is easy, not very complicated. Protocol is pretty simple. And the cabling is not that difficult. But there's a lot of complexity with it. It's not easy to administer. It's very difficult to add something to this, right? And it's pretty slow. So as we've moved on from that, we've moved into higher-end networking, which is beyond peer-to-peer. We moved into local area network topologies. And so one thing you really need to understand and get a feeling for is what are the different local area network topologies and what are the protocols that are engaged in them. The one that we're going to be focused on is Ethernet and modern switched networks. That's what we're going to be focused on here in class. There's a lot of old history we could get into, but I'm not going to bore you with all of that. Believe me, it's one of my fun pastimes to talk about network history. Ancient days, like 5 years ago, things were a lot different than they are today, right? So it's fun to talk about the morphing of networking technologies and businesses and who's come and rise and fall of companies. Now we're seeing the death spiral of Microsoft, which is interesting. Just like I saw the death spiral of Novell and Sun. So it's interesting to see how things change and evolve and morph, and we can really have fun talking about that. But LANs are important. Wide area networks called WANs are important, and the technologies that make those happen are important. The internet has brought around an interesting thing where LAN technologies and WAN technologies are kind of becoming similar, which is different than it was when I was younger, when I had a lot more to learn than you have today. So you have it a lot easier because you only have really one protocol stack to know. When I was taking networking classes when I was younger, I had like 4 or 5 protocol stacks I had to know. And so nowadays we only really have to know one thanks to the internet. All right, so let's talk about the basic components of the networking. There's basically 3 types of components. You have the actual devices that make the network happen. These are primarily routers and switches, right? So routers and switches are what you, with me, will be focused on for all the time you're in Cisco classes. We'll be talking about route and switch. So the CCNA program is all about route and switch. Now you may think, how is it possible to fill 4 full semester classes, 16 weeks long, or how many of our hours full, of just route and switch, right? 2 devices. Well, it is possible, believe me. There's lots of complexity in there, and we'll have fun talking about it. You also got media, connecting these devices together with various different types of media. So one type of media is called unshielded twisted pair, or oftentimes we just use the term copper. So copper unshielded twisted pair cabling. It has different categories. You'll hear the term category 5 or category 6. Right in here, we're using category 6 cable, this gray cable that you see running up here. That's category 6 unshielded twisted pair cable. And that's the type of media that we use to connect your machines with the switches they're talking to, right? Routers sometimes use different media. They might use fiber to connect the devices together, or other types of media that are possible as well. Wireless, some of you are on laptops back there. You've got your laptop. You are not using copper, I see. You're using wireless transmission, And the wireless access point is up in this little dome up here. So it's hiding up there. And the Cisco access point up there is propagating a wireless signal to you, and you're using that signal to communicate. So he's not using wires. So that particular media is a wireless media. So there's a variety of medias that we have to talk about in order to make this picture complete. And then, of course, we have services. Software runs the world, or at least Microsoft wants you to believe so. So software is a big deal. Email services, Eagle Advisor when you register, mobile applications that you use, web browsing services, file printing, all that kind of stuff. These are all services that we use and access. So there's a relationship between the services, the devices, and the media that we transmit on that we have to get and understand. And there's intricacies about each one of those that will impact whether or not they will communicate or whether or not they'll communicate well on a given network. And this is what we need to be experts on in order to solve problems or make recommendations to people. And that's why we're taking the Cisco courses. Edge devices, or what Cisco refers to as end devices. End devices are devices that receive an address on the network and are the recipient of all the devices and media that allow them to communicate on that particular network. And we have a whole slew of those that are possible, and the list is growing longer and longer every day. You got phones, right? You've got printers, you've got teleconferencing equipment, you've got security cameras. Just look around in here. Name all the things that are end devices in this building, right? You got the desktop computer. How about that projector? Yep, that's an end device. The teleconferencing equipment next door. The security cameras we have in here, right? The fire alarms. Some of the clocks. All of these. Mobile devices, printers, laptops.
Would the what be one of them?
What's that?
The
The wireless access point. Although Cisco doesn't really call that an end device. That is more like a switch. It's just a fancy switch because it does wireless, right? It trunks just like a switch does, right? So it's really just a switch, right? Then we have intermediary devices such as switches and wireless access points. They provide access. So this wireless access point or one of these switches right here, right? And all those switches back there in the server room. Those all provide access for these devices to connect to the world. And then we have routers, which are devices that allow us to route over a network. And then we have security devices like firewalls or proxy servers, things to protect our network. So all of these things are things that we have to deal with together and understand how they interoperate with each other. So a very complicated, fun world. By the way, networking people are never bored. Right? You're never bored as a person in networking. But if you're the kind of person that doesn't like to study and learn something new every day, then you're in the wrong field, right? Because you're always learning, but you're never bored. So it's kind of exciting, right? There's always a problem to deal with. Every morning I wake up and I've got some stupid issue to deal with, right? And I got to fight through it, right? And it's funny, like on Friday, I had this networking issue I was dealing with. I have this Isilon storage area network in my lab. And I've been messing with this darn thing all week. And I got it to finally work, and I'm all happy, I'm woohoo. And then something breaks. I don't know what it is. It just breaks on Friday. And I spent 8 hours on this stupid thing, and I never got it to work. So I went home all miserable, pissed off all weekend. This morning I walk in, and a light bulb goes on, and I tried something, and it works. Right? What the hell's that? Stuff like that happens all the time, right? That's just networking for you, right? So we got our media. We got copper, fiber, wireless, and those are all three of those we'll be talking about extensively, or you'll be going through as well. Then you got your end devices, your intermediary devices, and your network media. So and by the way, these are icons. One of the things that you need to learn how to do is drawing diagrams. A couple of times in class we'll be using Visio, and I can provide Visio to you free. I will be adding all of you to our DreamSpark program, where you'll be given the ability to download Visio at no charge. You can also get access to it on a remote apps.msjc.edu interface. This is what topologies look like. There are two types of topologies in networking that we deal with. We deal with a physical topology and a logical topology. Physical topology deals with the actual devices and their connectivity across media. And logical devices deals with the actual device, its role, and its logical addressing. You, by the time you're done with the first class, will be able to read both of these diagrams without much difficulty. Okay. It used to be I spent a lot of time talking about this because it's kind of fun. There's an organization that kind of governs this, and it's called the IEEE, i3es.org. IEEE is an organization of electrical engineers. So what happens is geniuses that go to MIT and other places that are electrical engineers write papers on really cool topics that you and I will never understand, like ad hoc wireless networking, right? Like, you know, or you just name the complex topic, right? Like the wireless signal propagation that makes your laptop able to talk to this, right? That magic voodoo that makes that happen, some guys created at the IEEE. They wrote a paper at IEEE and published it. Eventually, those papers trickle their way down, right, to the corporate world, and people take those ideas and make products out of them, right? And then those products eventually we buy, and then people like us have to learn them and know how to install them, right? That's basically how the world works, at least in my microcosm view. So the IEEE has come up with protocol standards. So just real quick, if you go to if you look at IEEE, I'll just show you real quick. Oh no, MSN has to load the Grammy results. Hold on. Dang it.
Mr. Reams probably waiting for that. Never mind, I'll ask him.
All right. So here's the IEEE, and on the IEEE they have this. You can look at the IEEE standards, and these are the standards that they work together on. These are where all the engineers together and create these standards. The one particular standard that we're looking at is the 802 project model, and we have to just find it. I don't know where it's at. You just have to keep looking. Yeah, here it is. These are the 802 project model standards. And there's just a lot of them. You can go through them all. Any one of the ones that start with 802 is the IEEE numbering scheme for networking topology standards. So all of these are up there. There's a lot of them. Now they have them all, and these are just a few of them. What you see here. These are just a few of those. Now instead of calling them 802.11 or 802.3 or 802.4 or 802. Whatever you want to call it, they've just given them names. And so one of them is called local area network, or LANs. And the other one's called wide area networks, or WANs. LANs and WANs use different types of technologies to communicate. Although that's kind of getting blurry. The reason why it's getting blurry is because technology's gotten cheaper and easier to implement. So Ethernet is typically a LAN technology, a local area network. And Ethernet is characterized by very crowded, very busy, very fast networks that are easy to move things around. That was never characteristic of a WAN. WAN are always very slow, very expensive, very long distance, right? Infrastructure-based, very difficult to make changes to. Well, that's kind of been changing. Because nowadays we have this 10 gig Ethernet thing, right? So suddenly we have the ability to kind of make rapid, low-cost changes even in a WAN environment. So things are kind of getting blurry. But these are usually two big distinguishing marks between the two. And there's various protocols, various media, devices, services, and protocols that work at these different levels, and they use two different types. So we need to learn all of those, and we're going to, right? In addition, there are other types. One of them is called MANs. This is for city networks where you can't actually trench fiber. The other one is called a CAN, Campus Area Network. Campus Area Network is where you can actually get a backhoe out and dig your own fiber, right? Like it's perfectly acceptable for me to get my backhoe tomorrow morning and dig a trench between these two buildings, 900 building and the 100 building, right, if I wanted to. Well, maybe not me, but the college, right? So we could do that. Now, I can imagine that it would be a problem if in downtown Los Angeles I decided to get my backhoe and dig a trench between the Arco building and the Staples Center. That might be a problem, right? So campus technologies don't work as necessarily as well in a metropolitan area. So in a metropolitan area, we use different technologies, right? We may use a lot of wireless, or maybe some satellite, or maybe infrared, or maybe some weird protocol that shoots from building to building. I don't know, right? Maybe the taxi cab protocol where it bounces off taxi cabs. I don't know, right? You get the idea. But then you have wireless LANs. And then you have storage area networks, like what I was messing with on Friday, my storage area network. So you have all these different ones. The latest one, which isn't on here, which is the hot one right now, is PANs. And guess what that stands for?
Personal areas.
Personal area networks. Now, 5 years ago, I would say PAN in a class like this, and everybody would laugh thinking I was joking. 5 years ago, people thought I was joking about PANs. Am I joking?
No.
Not now, right? I'm not joking now. Now it's serious business. Right now it's big money, right? PANs are where all the money's at right now. And I remember I first started talking about PANs when they started coming out about 10 years ago. And I was talking about Zigbee and all these different things that were coming out at the time. And everybody's like, yeah, whatever, big deal. Well, now it's a big deal, right? Because think about it. Every one of us have our own little personal area network going on, right? Wearable. A thing I wrote a paper on a few years ago was called wearable computing. I was making a serious case in that paper that wearable computing was going to be the next big wave. Where are we at now with wearable computing? Do you think wearable computing is a serious market driver today, or going to be?
So far, we got glasses.
Yeah, I mean, look at where this is heading, right? They're in development of devices that will charge off of your body heat right now. I mean, that's just nutty, but off the kinetic energy, if you move it around, you'll be able to charge a device, right?
Auto-winding watch.
What's that?
Auto-winding watch.
Yeah, well, they already have that because it something to do with the gyrotechnics of it all.
I don't want to be too old.
iPhone 6 wireless charging.
Yep.
I don't want to be too old, but those watches that used to move and charge
Yeah.
and one.
Does anybody remember the Timex watch you'd hold up to your monitor and it would transfer data? Do you remember that? Does anybody remember that? I had a Timex watch, and if you held it up to your monitor, it had a schedule on it. And you hold it up to your monitor, and your screen would flash in like some weird binary code, and the watch would pick it up and download the schedule of the watch, and you'd have your schedule on your watch. I remember I saved every dime I had and bought that watch. I was like a sophomore in high school or something. It was funny. Yeah, I was the only one, and I think all high school that had one of those things. The only geek that we wanted to wear one. But I back then I knew that being a geek was going to be cool, right? I saw the future. Yeah, at least lucrative enough to be a geek, right? I saw it coming. I'm like, I see this gravy train. I'm jumping on this shit. All these other lawyers and doctors, whatever. I'm not putting all that school in time. I'm going to do nothing to get paid. All right, so that's what I did. All right, so there we go. All right, so LAN, they're talking about that. WAN. So WANs, you know, you're taking LANs separated by long distance. It's normally expensive. The protocols, communications, devices to make this happen are a lot different than the protocol, devices, communications to make this happen, right? So we got to talk about that and throughout the classes. By the way, Net 100, Net 101 is primarily focused here. And net 102 and net 103 starts to move into here. Right? That just gives you an idea of where the classes are at, right? Of course, all of these little WANs and LANs connect together to this big internet. Right? By the way, there is no internet. The word internet is this misleading term. There's really just a bunch of companies connected together by loose agreements. And I can't emphasize enough that those loose agreements are in extreme jeopardy. Right? We're in a very critical time right now. And most of you, us, people in the United States have blinders on when it comes to what Congress is doing with those loose agreements. So we are in danger of this very awesome thing that got built out of the idea of freedom being completely destroyed. I hope you know. So I'll get off my soapbox now, but wake up, because this thing ain't going to be around much any longer. It's already gone, by the way. There is no internet. It's just it's companies loosely tied together by agreements, and they're already charging tariffs for those agreements. I don't know where it's going to be in 5 years, but it's going to be free, right? Like it is now.
There's the DNS people that control the.
Well, DNS has really nothing to do with it. DNS is just names.
Right.
Names have nothing to do with
But
it.
if you didn't have that, who's going to write to the proper?
Well, names are important, but the connectivity between the networks are more important.
That's where you do.
And that's where the battle is happening.
Verizon already had it recently, right?
Yep, big battle in court.
They just opened DNS services out there.
Yes. But DNS is not the battle.
It's a line holder.
The Verizon MAEs are where the battle's at, right? This is a big, huge battle going on right now. Who owns that? Who has rights for it? Who controls it? Who monitors it? Tons of court cases are on this going on right now. So it's pretty important. All right, let's talk about these three terms. Intranet, Internet, Extranet. So in the business world, we have this thing called an intranet. That means in my own company. That's my intranet. Sometimes I'll have an intranet website. Only my company can see, right? Then I'll have an extranet where my suppliers, companies, customers, vendors, partners of mine can also access. And then the internet, which is my world presence, right? So I'll have guyreams.local, which will be for all my employees to see, me and myself, right? And then we'll have the extranet where any vendors I do business with, I might have a purchasing site that they can access, right? And then the internet might be the guyreams.com portal where everybody can hit, right? So if you're running a company, you have these three visions of the world. In today's world, the big issue is connecting remote users to the intranet, to the extranet, or to the internet. Getting people connected through DSL lines, cable lines, cellular, satellite, dial-up, telephone, modems, Verizon files, whatever the case may be, getting people connected is one issue, and then getting them securely connected to the company is another issue. And the term we use for that is called a VPN, or a virtual private network. All right, let's talk about networking as a platform. What does the word convergence mean? So the 90s was all about convergence. Not really centering.
Sharing.
Sharing
One
is the
network.
word, yeah. So rather than having disparate networks of computer, telephone, voice, video, networking, right? Rather than having disparate networks serving different purposes, 3 or 4 different infrastructures requiring different devices and equipment, rather than that, if I can merge them all together or converge them all together with more expensive equipment like Cisco switches, right? Then I could save on all of the money it took to have these 3 disparate systems, and I could converge them together on one platform. So in Cisco's mind, the network is the platform by which you can launch all these different applications and services such as voice, video, data, you name it, across the platform. You follow me? And the platform could extend across the WAN, or could extend across the LAN, an intranet or an extranet, doesn't matter. See, look at all these cool geeky terms you already know. Just in 1 hour, you already know what a LAN is. We're already talking in acronyms. We're just 1 hour into it. All right. Okay, I don't want to talk about that. All right, so as we start to evolve these networks to handle more converged infrastructure, so as infrastructures start converging, we start having challenges, right, with that concept. So one of the challenges is fault tolerance. And what do you think that means? It's not necessarily two things getting there at the same time. It's having multiple paths, so if one path fails, I at least have a way to get there. Yeah, redundancy. So fault tolerance is making sure that services stay up. Like, I mean, how devastating would it be for Google if Google.com stopped working? Right? Like, I remember one day Google.com had a hiccup for 15 minutes, like 10 minutes. This was about 4 or 5 years ago. Does anybody remember that? It was like February 17th, 2011. Google stopped for 10 minutes. And it was like the world stopped. Like, I can't imagine what would happen if Google stopped today. I mean, their number of users have almost exponentially increased since that time. How many of you are just like Google every day? How many of you type the words www.google at least once a day? I mean, most of us do. Or you see the Google splash page, right? Every one of us, right? We're all Google users in some fashion, right? So imagine if Google stopped working. We would think our lives were over, right? It's like, right? So that would be horrible. So Google has to have absolute 100% uptime, right? For a lot of services, it's that way. Maybe not 100% uptime, but at least 50% uptime, or we usually measure it in nines. Do you know what that means? We say the nines. How many point nines I want to be up? So how many is 4 nines? That's 99. Somebody get a calculator out for me. So let's just talk about it. So if I have 99.9999, no, 99.99, that's 4 nines. 99.99. Somebody multiply, divide 365 by that. That's how many days are in a year. Actually, we have to do it by hours. Multiply 365 times 24, get that number, and then take that number and divide it by 99.99, and let's find out how many hours that is.
87.6.
87 hours? That seems high. What?
87.61.
It's 87 hours. So 4 nines means it's okay for me to be down 87 hours out of a year. It seems like a lot, doesn't it?
Yeah.
It's 87 hours worth of downtime. So 4 nines is not Google territory, right? Let's see what 5 nines is. So somebody do 5 nines multiplied by the number of hours in a year.
87.6.
What?
87.6.
So we can be down 87.6 hours? What's 6
No,
nines?
just keep that.
80. The float keeps shrinking, but it's still 87.6.
Oh, the float shrinks.
Yeah.
Okay. Anyway, you get the idea. We start measuring downtime by hours and minutes, right? So there you go. So how many days are in 87 hours? 4 nines is about 4 days, I think, is what we usually say.
3.5.
3.5.
A little over 3.5.
So the next thing is scalability. Do you think a company like Google needs to worry about the term scalability? What does that mean, scalability? What?
So easily it changes based on the size of it.
Yeah, as you add numbers of subscribers, you need to go. Does anybody use Google Mail? Okay, I've sat back and watched the Google Mail little number of how much storage I have increase slowly in awe. Has anybody done that? I sit there and go, wow, it's growing, right? I don't know how they come up with that. Like, I really want to know. I should research that. But the number's just kind of growing, right? That's called scalability, right? So as your number of subscribers grow, you want to scale, right? You want to scale your operation. You want to scale your... So if you have a finite number of devices you can add to your network, that's not scalable. So you have to have built-in networks that are fault tolerant, but are also scalable. So we can grow this thing, right? Or scale up to what I think my max growth would be. That's scalability. Next one is called QoS, another acronym for you. What does that stand for? Quality of service. What do you think that means?
How reliable it is, how fast it is.
It's not reliable. Well, a little bit of reliability, but not much about reliability. Not really much about fast either. See, most devices work on a queuing kind of idea, thought process. Right? So normally when information goes past the device just flows past, lets it go as fast as it wants to, right? Whatever, just keep going.
MTBS.
Yeah, a little bit. But what's happening here is that the stuff comes into the switching device. Eventually, we may have so much going across the device that it gets stacked up or queued a little bit, right? Now we have to make a decision. Do we send it out on a first in, first out basis, or what we call FIFO? That's one strategy, first in, first out. Sounds fair to me. But what happens if you're my CFO and you and I are having a telechat? And it's a big, important call. You're the CFO, I'm the CEO, we're having this big meeting, the shareholder thing's about ready to happen in an hour, and we're trying to have this big meeting over a phone conference because you live in Quebec and I'm in Los Angeles. And then suddenly somebody decides to download the latest cat video on YouTube, and boom, we don't have a call anymore because the cat video is more important, right? Is that okay?
No.
No. That's QoS. Instead of first in and first out, we decide, you know what? The CFO, CEO call is a little bit more important than the cat video. Right? And then finally, the last one, security. What's that?
Hackers.
Well, it's a lot of things, right? First off, it's security of the data in transmission. To make sure nobody like the NSA can be stealing it, right? We don't want anybody stealing the data, right? What else? We don't want anybody tweaking the data, right? Because what I send is what I want to send. I don't want it to get changed during transmit. That would be a problem, right? How about this? I want the CFO to send me something. I sure hope that it was the CFO that sent me that and not somebody else, right? Not somebody faking to be the CFO. That would be a problem, right?
What was the password?
Yeah, that could be a challenge, right? Or worse, the CFO claims that she sent me something, but I deny it. There's a little non-repudiation issue going on there, right? So we got that security issue, right? So we can just go down the list. I got like 20 of those, right? There's like a list of things that could happen, right? Also, I want to make sure that there's some integrity to my data. Target had a little problem recently. Did you follow that one?
A little bit.
Yep.
That's a little bit of an integrity issue, wouldn't you say? I mean, how many zeros at the end of the decimal point do you think that's costing Target? That's just mind-numbing how CEOs don't plan for that kind of crap to happen, right? That's just, right? And now you wonder why the IT guys are so anal about their rules, right? Something like that goes down, and you're like, right? So that's a huge deal, right? My favorite story. I knew this guy this guy at the Bank of Chicago, and they had about 70 or 75 branches, and a disgruntled employee got fired from the company. And right before he left, he made one small change to an area code he should not have had access to, but he did, right? And he was able to log on to a device at remote branches. He should not have been able to log onto these devices remotely. The network security is very poor. And he made changes to all the ATM machines, which is real easy to make. He basically squared all the transactions. So what does squaring a transaction do?
You take out $100, you take out $10,000.
No, it's not it. Any negative looks positive. That's the result of squaring, right? It was really easy to reverse engineer it and know that, well, he squared it, so 10 times 10 is this, so we'll just reduce the square, no problem. But how would they know if it was negative or positive? Because when you square something, it's positive regardless, right? So all the negatives are removed. So everything for like a week looked like deposits. I used to have it. I lost it. I'm so mad that I lost it. But I had the letter that the Bank of Chicago issued to all their customers. If you made a transaction between this day and this day, would you mind please sharing us your receipt? Because they had no way to prove whether or not you had a withdrawal or a transaction. So they had to count all of those as deposits. Isn't that brutal? So there you go. The ramification, and I don't even need to get crazy on the ramifications of security nowadays, right? I mean, just think of all the stuff in the news. Just every day, wake up and go to Drudge Report or someplace like that, and there will be 2 or 3 network security issues in the news every day today. It's really amazing. I mean, we've really come hypersensitive to that these days, which is great for guys like me, right? Yeah. Yeah, social media has just exponentially increased the security issues dramatically. I mean, it really has. But device security is actually more important. Because if you control the device, right, it's bad, right? If you can control the device, game over, right? You can do a lot of stuff with software that we can patch and fix. But if you get somebody who can control your devices, it's over, right? So access control, permissions-based control, all these things are stuff we have to deal with in security. So there you go. So blah, blah, blah. So there's lots of redundancy things we're going to talk about. All of this gets into the Net 102, 103 classes. But talking about fault tolerance and switch networking, having multiple path networks, such as in a circuit switch network, like a telephone network would be, or in a packet switch network, like a router network would be. One of the protocols we're going to talk about is called frame relay. And that's a protocol that is capable of path redundancy in a packet switch environment, right? So all of these are WAN type of reliability issues. Scalable networks, being able to add more networks and grow our networks as required. Another big issue that deals with high-end protocols, which we'll talk about. QoS, I already talked about. I'm not going to get into that. Network security. Network security is handled in lots of different areas. At access policies across all of our devices, at firewalls at our perimeter, encrypting data as it's being transmitted across, and a whole slew of other issues. All of these are controlled by protocols and by devices. All right. And let's just talk about some of the new trends. So you cannot be on a conference call in modern corporate America without hearing the term BYOD at least once in the call, right? Everybody's talking about BYOD. It'll always say something like this. Well, have we thought about adopting a BYOD policy? Right? They'll always say something to that effect, right? And the reason is because people are going to do it anyway, right? You can't stop them from bringing their iPad to work. And why am I supplying? Because the company wants to supply you with a Microsoft tablet because they're easier to control than the Apple. But who wants to use a Microsoft tablet, really? Right? I mean, I have a Microsoft tablet in my bag, and it's been sitting there for about 8 months. I've never turned it on, right? Because it's just so freaking annoying to use. So I'm not going to do it, right? I have my Droid tablet, which I use all the time. So, and I have my Droid phone. The company issued me a BlackBerry. I'll never use that thing. That hit the junk drawer the second I got it, right? I'm never going to use that. Who uses a Anybody here a BlackBerry? That's pretty telling. Yep.
Corporately, I know they're used in my company. They issue them. They still do.
Yeah, but that's slowly dying. You know it's dead when the executive gets an iPhone. which probably has already happened. I'm just guessing,
Yes.
right? Everybody else has to use the BlackBerry, but you know the death throes are happening when that occurs. Now IT's researching BYOD policies. Could we do this with the BYOD plan? And then things are coming up, right? And so, but all the different networking issues, security issues, we have to deal with that with BYOD. Online collaboration. This is changing, right? It used to be we had these really complicated telepresence systems we'd have to put in, right? But nowadays we got WebEx or GoToMeeting, right? Online meetings made easier, right? You hear advertisements on the radio now for GoToMeeting. So nowadays we're talking about mobility, IP communications, telepresence, online conferencing, messaging. All of that stuff is now being part of our everyday experience. Messaging used to be like a fad, like, you know, a little IRC chat thing was just like a gee whiz thing. Nowadays it's like a requirement, right? You know, having Skype or whatever. Like Skype nowadays in corporate America is almost a default install on every machine, when that was unheard of 5 or 6 years ago. But
That's
Skyping, chatting, talking, all these things have become very common.
That's because Microsoft got it.
Yeah. Video communication is becoming a bigger and bigger and bigger deal, right? It used to be that the video phone was just kind of a laughing Star Trek thing. That's changing slowly. But I now have FaceTime is a good example. But on my phone, I have face-to-face chats on my phone all the time with people now. So, and what's really nice about it is I'm able to show a camera from in my lab and show anything, or they can see me or see a picture of what I want them to see. So that's becoming very commonplace. So video is becoming very dominant. And these are real numbers. Pay attention to this. In 2016, Cisco is projecting that 62% of all internet traffic will be video. 62% will be video. That's incredible. Oh yeah, yeah. About 80% of that 62% will be Netflix, right? But, or Hulu, right? But you get the or yeah, or cats. Yeah, there you go. But yeah, you get the or YouTube, right? It's amazing, right? You have people now are making entire careers of just video streaming. It's actually more lucrative now to leave broadcasting and start your own channel, right? It's more lucrative now. Like, to use an example, the radio personality, his name is Glenn Beck. He got hired by Fox News. You might know him, he's a little whack job on Fox News. He got fired from Fox News, which was the best thing that ever happened to him. Because he started his own online video internet channel and started broadcasting it. He made more money last year annually than Oprah's O Network did in the same year. And that's saying a lot. Anything Oprah touches turns to gold. He made more money in internet subscribers than Oprah did on O. Right? That's crazy. One guy out of his own house with a small camera and an internet connection, that's just nuts. That's what's happened now in our society, right? And he's just one example. I could pick 30 of people that have made a lot of money broadcasting right out of the comfort of their own living room, which is incredible. I'm trying to do that.
You are.
Fred's part of it. You're joining the revolution. Starting tomorrow, man. All right, then cloud computing. Okay, it's not really called cloud computing. It's actually called Amazon AWS, but we just call it cloud, right? So it's really Amazon, right? So Amazon somehow cornered the market on cloud. And to be fair to the people that try to compete, we call it cloud instead of Amazon. But really, this concept of being able to use the internet as a platform to be able to launch applications to mobile devices in what we're now calling the cloud has really become quite incredible, right? And just think of all the businesses that have started off of the cloud model, right? I mean, you and I could sit down and start going over all the business models that evolved out of the cloud in the last 5 years. So when I got, in 1998, I got a job offer for a company down in Irvine that started an organization that was supposed to deliver applications over the internet. This was in 1997. The company went on the stock market and then flopped and went belly up. It was not ready yet, right? But they had in their business plan the idea of delivering applications to mobile devices using the internet. This was their big thing, right? Completely failed, but they were just too ahead of their day, right? But now that Apple came around and revolutionized the mobility world, cloud has now become a reality.
Yeah. How does Amazon fit in there? Right? Is it that's the cloud?
Well, they are the cloud. They provide the infrastructure to support the applications and the services
I
to
understand
connect.
that, but that's Microsoft, and so that's the iPhone.
Yeah, but Microsoft and Apple and these other guys trying to play have like a 2% market share, and
Oh, I see.
Amazon has a 95% market share.
Okay. Yes.
Yeah, and Google is on AWS.
So they're on their data centers.
Yeah. Everybody is on AWS. I'm being a little over-exaggerating, but not by much. Amazon, there are other cloud providers. There's like 5 or 6. And then you have the big emergence nowadays is private cloud, which is what I'm starting to get into. So I'm kind of shifting my focus on private cloud. So private infrastructure cloud is where things are going. Companies that don't trust Amazon and don't buy into the Amazon way, which is, Amazon, by the way, doesn't pay people money anymore. They pay you in Amazon points and Bitcoins and stuff, crazy stuff like that. So Amazon's kind of trying to change the financial model for doing business on the internet. And a lot of people aren't getting into the program. So there's a lot of private clouds starting to emerge to do what I want to do, but in my own little private cloud. Medical companies are the first to do this. They're creating private clouds to support their way of delivering services over the internet.
Data sensitivity too.
Yeah, that too. Although Amazon has a lot of ways to protect that. But you remember Amazon went down not too long ago. A couple of years ago, Amazon had a hiccup. Boy, the world stopped. That was great because all the services that we use, all the apps we use, when you're on your phone, you got ads and stuff popping up on your phone. You're watching YouTube videos. You're doing all this stuff is coming out of an Amazon data center somewhere. And when that stopped, it's like, ugh, right? All the apps stopped. All the email stopped. Right? Just crazy. Google doesn't use Amazon exclusively. They have their own data centers too, but they use Amazon a lot.
I'm having a lot of trouble with WD. I have a 2 terabyte, and of course the Java generated. I'm having a lot of trouble with them. It's, my son is having trouble coming into into my stuff. Everything is set up properly.
Yeah.
Is that an indication of just is it Western Digital or is it support in general?
Networking issue.
It's a networking issue. Yeah.
Amazon's
And it's also Windows Storage Server, which is running on the WD device. Yeah.
Amazon's market share is 28% by revenue.
28% by revenue.
28%. But it's still more than Microsoft, Google, and IBM combined. Way more.
Yeah, cool. So in the cloud space, Amazon is dominant, but there's a lot of cloud providers. Now, what are they calling a cloud provider? So the definitions get kind of murky here.
Yeah.
Because if we start talking about shared applications, they may be excluding Amazon out of that. So it's kind of different.
It just says Amazon AWS.
Okay, so AWS only. They're not talking about Amazon data centers.
Here's an ad for Google Cloud.
Yeah. Which incidentally uses Amazon infrastructure. No, Amazon is pretty dominant. They're not. I'm over exaggerating the case a little bit just for fun, but Amazon is pretty dominant in the cloud environment. Everybody right now is considering Amazon the enemy. So if you were to go to an EMC conference, they would be saying Amazon's the enemy. If you go to a Microsoft conference, Amazon's the enemy. Cisco, Amazon is the enemy, right? Because they're trying to change the model for the way people get paid. All right, let's keep moving on. Data centers. Data centers is the modern, well, it's where everything happens today, right? Whether it's in an Amazon data center or in a Google data center or in a Microsoft data center or wherever it happens to be, the data center is where it's all happening. If it's your company's data center, if it's a co-located data center, it's a hosted data center, doesn't matter. It's that data center. Wherever it happens to be, the data center is where it all happens. And data center technologies are where Cisco focuses all their time and energy, because that's where all the money is made. Somebody will drop millions of dollars just to show you. Let me show you the latest spaceship.
They're barge.
No. So this is the latest switch that Cisco is pushing, and this is called their Cisco Nexus switch line, right? So this is what it looks like. This is a Nexus switch, and you walk into. Okay, so I walked into this data center in San Bernardino, this regional data center in San Bernardino, and I was there a couple weeks ago. Walked in, and Cisco is so arrogant. They want to make sure that their switch is in the middle of the data center. Now, it's not because they're just arrogant. It's because they want the cables to have a shorter path, so I'll give them that. But right in the middle of the data center is a Nexus switch with all these colorful yellow, red, and blue cables coming out of it, fanning out. And this thing looked like Star Trek. I mean, it was like amazing. It was glowing. In fact, the front face shield kind of glows. It kind of vibrates, right? So here's the Cisco. You know, these big old fans are sucking air through the bottom. It's kind of making this low humming noise. I mean, you feel like you're something just to touch this thing, right? So this is the Cisco Nexus. You can't get a price on this. It's like too expensive. Forget it, right? But you can buy individual blades. You buy the chassis, then you buy the blades and the ports. They sell it by a per port cost. It's expensive.
Price is medical account.
Yeah, exactly. Yeah.
What's the
But this is
maximum?
the Nexus switch line. So that's Cisco's latest and greatest. But this lives in the data center, right? This is the hub of the data center. By the way, Cisco sells servers now. It's called Cisco UCS, or Unified Compute, right? Unified Compute System or Solution. So UCS resides on top of the Nexus. And the Cisco Unified Computing Infrastructure ties into Nexus to provide you with servers and workstations for desktop computing. So all this resides in this core hub that is called Nexus, right? So that is where Cisco's got their heart and soul, is in that right now, right? Incidentally, we will not be talking about the Cisco product lineup on any of our classes. But it would be fun to a little bit anyway. But a Nexus device has redundant connections. They have high-speed virtual servers, hint Cisco UCS. Redundant storage systems, redundant backup power supplies, redundant fans, redundant air conditioners, redundant everything, right? Redundant security apparatuses, right? Because we want to make sure that we have that 5, 6, 7 nines of operation. All right, this boring stuff about technology in the home. You know, there's a lot of stuff happening in the house too, right? Wireless connection, wired connections. People are now sending Ethernet data across your power lines. You got devices that do that now. You can get 10, even now 100 megabit Ethernet over your power lines in your house, which is kind of cool. Has anybody done that?
Friends and extend that.
Yeah, I did one until my 3-year-old touched it and almost burned her hand off. But yeah, they get really hot. But yeah, it's pretty cool. And then wireless connections in the home are pretty powerful. Wireless broadband is becoming more and more expensive and cheaper. They now sell services where you can combine multiple services together and have spread spectrum bandwidth across multiple providers to increase your your speeds at home. So it's kind of pretty cool. I don't know how expensive that is. And of course, we got, you know, threats at home. At home, there's just a lot of threats that we can deal with. Viruses, worms, Trojans, spywares, hackers, denial of services attacks, interception, identity theft. And of course, there's lots of solutions that we're going to deal with in this class. Firewalls, access control lists, intrusion prevention, and virtual private networks are some of the security solutions that we'll talk about in the next 4 courses. All right. So, just to recap, these 4 courses are going to start you out here. You will have the ability to get to the 2nd level of the pyramid, right? And if you so choose to make a career out of this, you can try to get up to expert level. Don't even worry about architect level. That didn't happen. Right? Just don't even. If you want to set a lofty, unattainable goal, go ahead and do this. But I don't know very many people that have achieved this. And they're real. They don't have lives. They're total geeks. So just give it that. Just say it. So just go to expert level.
Kind of flat pyramid.
Yeah, I know one guy that's an architect, and he's just not fun to talk to. So just there. Just stay at expert level, right? So and all of them work for Cisco too. And who wants to work for Cisco? Me. So there you go. All right. Any questions about what we went over? Awesome. All right, I got one more thing to cover, and then we're going to quit. First off, I want to see if my little thing happened.